Now we're going to look at the next conic section, which is an ellipse. So ellipses have a formula somewhat similar to circles. They have x minus the x coordinate for the center, that all squared, plus y minus the y coordinate for the center, all squared. This time it equals 1, and each parenthesis is divided by a certain number. So a squared represents the horizontal radius squared, and b squared represents the vertical horizontal radius squared. So if we were to look at this graph of an ellipse, this is just one instance. This is if A is bigger than B. So the distance from the center to the x vertex, I guess, is A. The distance from the center to the y vertex would be B. And in this case, since A is the biggest one, those are actually the vertices, and the vertical ones are called the co-vertices. Alright, let's do an example. We want to graph the ellipse, identify the center, vertices, and co-vertices. So if we look here, our center comes from the numbers in the parentheses, and we change their signs. So our center, in this case, would be -2, +3. Again, we change those signs. So let's graph that. -2, +3, be like right there. And then let's use this number underneath the x parenthesis to find our horizontal radius. So this is equal to that number squared. So 9 is equal to a squared, and if we take the square root, we get that a, or the horizontal radius, is 3. So we're going to count 3 to the right and the left of our center and draw that radius. So 3 to the right, 3 to the left. Alright, now let's find our vertical radii. Now if we look here, this parenthesis is not over anything, or at least it's not written that way. Whenever you see something like this, it's actually divided by 1. But anything divided by 1 is itself, so we don't actually have to write that. So we know that b squared is equal to 1. So if we take the square root, b equals 1. And that's how far we're going to go up and down from the center. So we go up 1 and down 1. And then we can go ahead and draw our ellipse. Now our vertices are going to be the ones that are farthest away from the center, which in this case they're going to be the points on the left and the right. So this first point is 1, 3. And that second one, let's see, that's 1, 2, 3, 4, -5 and 3. So there's our vertices. And for our co-vertices, those are the ones that aren't as far away from the center as the vertices. And in this case, they're just 1 away. So the coordinates are -2 and 2, -2 and 1, 2, 3, 4. So -2 and 2, and -2 and 4. Okay, so there's our graph of the ellipse, and here's our characteristics that we needed. Let's go ahead and do another one. Alright, so here's our equation. So first of all, let's find our center. And the center points come from the x parenthesis and the y parenthesis, and we change those signs because it's x minus the coordinate and y minus the coordinate. And in order to get a plus, you'd have to have a negative, so this would be -2. And the first one will just be +5. So let's graph that. 1, 2, 3, 4, 5, and -2. Okay, let's look at our horizontal and vertical radii. So the horizontal one is under the x, and that is 9. So we actually know that a squared is equal to 9. So if we take the square root, a, or our radius, is equal to 3. So we're going to count to the left and the right 3 units. And then for our vertical radii, we're going to look at the number under the y parenthesis. So that's 16. So we know b squared is 16. So b is equal to 4. So we're going to go up 4 and down 4 from our center. And then we can go ahead and draw that ellipse. Okay, there's our graph. And now we would need to identify which are the vertices and co-vertices. So since in this case the vertical radius is bigger than the horizontal, these green points are going to be our vertices. So our vertices will be 1, 2, 3, 4, negative 5 and 2. Oh, nope, that's a positive 5 and 2. 1, 2, 3, 4, 5, 2, yep. And 5 and negative 1, 2, 3, 4, 5, 6. Okay. And then our co-vertices will be the red dots. So that's going to be 8 and negative 2, and 2 and negative 2. And there we have our characteristics. Next, let's go ahead and write an equation for an ellipse given the graph. So we have our graph here, and a good starting point would be to find the center. So let's see, let's write our basic form of the equation. So we're going to have x minus something squared over something squared plus y minus something squared over something squared is equal to 1. Okay, so the center has got to be halfway between each set of vertices and co-vertices. So let's see, this goes down 1, 2, 3, 4, 5, 6, 7, 8. So halfway would be 4 units away, which would be right there. And that point is at negative 3 and 1. So our center is negative 3 and 1. So that means we're going to plug negative 3 into our x-coordinate spot and 1 into our y-coordinate spot. Now let's focus on finding the horizontal radii. So that's going to be the distance from the center to the vertex. So that's going to be 1, 2, 3, 4, 5 units. So we're going to plug 5 in there. And then the vertical radius is going to come from the distance from the center to that point. So that's 1, 2, 3, 4. So we can plug in 4 there. And then we just simplify. So we'll have x plus 3 squared over 25 plus y minus 1 squared over 16 is equal to 1.